Here's an interview question which was asked for a quant role in Citadel as well as Five Rings Capital. The question goes, suppose you have suppose you randomly generate points xy on the circumference of a unit circle, radius 1, centered at the origin. What's the variance of x? So the question says we have a unit circle around the origin. This is 1. This is the x coordinate of any given random point. This is the y coordinate. And we are expected to find what's the variance of x. So let's take a look at how we can solve this problem. Any given point on a circle can be expressed as r cos theta and r sin theta. So let's say this is the radius, this angle is theta. The x coordinate would be r cos theta. This is the point x here, this distance. And similarly, y, the vertical distance, would be r sin theta. Now, in the question, we are given that r, the radius, is 1 because it's a unit circle. So the x coordinate becomes cos theta and the y becomes sin theta. And the angle theta becomes our random variable, which without any given constraints or any other information, we assume that it's uniformly distributed between 0 and 2 pi. So now we have the variables in terms of theta. We need to find the variance of x. So variance can be written as expected value of x square minus expected value of x whole square. Now, expected value of x, what would this be? This becomes expected value of cos theta, which is equal to 0 because cos theta is symmetric around the circle. Then we have expected value of x square, which becomes expected value of cos squared theta. Now we know that expected value of x square is x square f of x dx integrated from negative infinity to infinity. Now, what is f of x here? F of x is our distribution function. In this case, we just saw that the distribution of theta is uniform. So what does f of x become for this case? Now, because it's distributed from 0 to 2 pi uniformly, f of x becomes equal to 1 over 2 pi because it's a uniform distribution. And the integral limit becomes 0 to 2 pi because that's the range of our random variable. We don't have to go from negative infinity to infinity. And x square is cos squared theta. So this whole integral becomes expected value of cos squared theta equals, now 1 over 2 pi, this part is a constant, so this will come out of the integral. So we have 1 over 2 pi outside. Integral from 0 to 2 pi, and then cos squared theta d theta. So now we have to integrate this. So you'll see that we are integrating with respect to theta. So we need to convert cos squared theta into theta. And we'll use this trigonometric identity. Cos squared theta equals 1 plus cos 2 theta by 2 to convert this into cos theta. And then we integrate and then plug in the range of theta to get the value. So we replace cos squared theta with 1 plus cos 2 theta by 2. We integrate this, plug in the range, and this gives us the final answer, which is equals to 1 by 2. This is the variance of x. So pretty straightforward problem, not difficult at all. You just had to know this formula for variance, the basics of expected value calculation, and a basic trigonometric identity. And that's all you need to solve this problem in the interview. For more such practice problems, you can visit datalooper.com/blog. We have a collection of hundreds of problems for roles in data, quant, machine learning, AI, and so on. Thanks for watching and see you in the next video.